So, when talking about relativity, I want to talk about real quick about its momentum. When we refer to the momentum of an object, remember that it's the natural tendency for an object to continue to move in a straight path. And that momentum is based on the object's velocity. So, when you start talking about relativistic momentum, remember that velocity is the point of view of the reference frame. So how much momentum that object has depends on that reference frame. So if an object is traveling very, very fast, we tend to think of it having a tremendous amount of momentum, which means that it's much more harder to get that object to move. Okay? And if you kind of think about it this way, so I have an object that's moving very, very fast in this direction, and I want to apply a force to change that object's motion so that it now moves in this direction. Because of the differences in the reference frames, because there are differences of the point of view, that this push is experienced over a different period of time from the point of view of this object as from the point of view of the object that's doing the pushing. Okay, so they're both experiencing time at a different rate. So instead of using the classical equation for momentum, we have to use a new equation for momentum. And it's actually quite simple. Okay, so that's the momentum of an object that's moving at a relativistic velocity. And remember that gamma is equal to 1 over 1 minus v squared over c squared. Now, this equation has in the past been the thing that justified this idea that matter increases as an object gains velocity, or mass I should say, not matter. I don't like to think of it that way. The reason why I don't like to think of it that way is because the chemistry definition of mass and matter tends to be the amount of stuff that you can put into a box. The physics definition of matter is the definition of inertia, which is this resistance to an object's change in motion. So an object that's traveling at a relativistic velocity would have greater inertia, but not necessarily greater mass using that chemistry definition. It's not going to pick up electrons, protons, and neutrons. It's not what's happening. Instead, what's happening is it's picking up more resistance for a change in its motion. That whole experiencing time at a different rate in which the object's applying the force. That's why it seems to have a greater inertia. Okay? So don't get hung up on the idea of mass. Think more of it as inertia, as this natural tendency for an object to continue to move in a direction, or to continue to move in its motion, I should say. Okay, so that is the momentum equation, and to be honest, I would rather have you describe that the object's momentum is going near infinite instead of mass and inertia. It's just a personal preference of mine. Okay, so that's the equation for relativistic momentum.